We're going to use the law of cosines to find the missing angles in this problem because I have no angle side pairs. There's nothing that I know both side A and angle A, for example. So that's going to be our cue to use law of cosines. Now, since we have a choice of which angle we find first, we're always going to find the biggest angle first using the law of cosines. I'm going to know that angle B is the biggest angle because side B is the biggest side. Always find the biggest angle first because law of cosines is the only way to find or an inverse cosine is the only way to find a possible obtuse angle that might be lurking in your problem. So we're going to find angle B first. Well, the way this works is, since in this case we're going to end with angle B, that's how law of cosines happens or is. The angle is the angle's in the back. Since we're ending with angle B, we're going to start with side B, which is 27. So 27 squared is my side. I'm going to put that equal to the other two sides squared added together. So 11 squared plus 20 squared. Now it's kind of like Pythagorean theorem. 27 squared equals 11 squared plus 20 squared. However, that only works for a right triangle. Since this one's not right, we need to do an adjustment. And that adjustment is to subtract 2 times, repeat the two sides, 11 times 20, and then cosine of B. So that's how I remember how to get this set up. Now, solving this can be a little bit tricky depending on how you try to do this. So I'm going to kind of go step by step and show you what I do. So first thing is I square all these pieces. So 729 equals 121 plus 400. And now the key is to remember this is one single term over here. I can't separate these pieces. So I'm going to do all that subtraction. That's negative 440. But then cosine B is still attached to that. So what some people do incorrectly is they try to add those three numbers together. They try to do 121 plus 400 minus 440. That will not work because that 440 is not by itself. So what I do is I think of just subtracting off these first two pieces. So subtracting 121, subtracting 400 to get rid of those two pieces. What's left then is 208 is equal to negative 440 cosine of B. At this point, what I'll need to do to get rid of that negative 440 is not add it, but since it's being multiplied by cosine of B, I need to divide by negative 440. That's usually the number one mistake I see people make when they're doing law of cosines. Dividing this out, this comes out to be about negative 0.4727. We've talked about rounding in the other videos. Even though I round off when I write these down, typically on my calculator I don't round, I just use the entire number that my calculator shows me. At this point, now that I've got down to just cosine of B, to find angle B, I'm going to do an inverse cosine of negative 0.4727. And at this point, I see that B is in fact an obtuse angle. Doing an inverse cosine is the only way to find, oops, not negative 121, what am I looking at in my notes? It comes out 118.21, that's where I saw the 21. 118.21 degrees. It's obtuse, and the only way to find that is with an inverse cosine. So I'm very glad I found that largest angle first. So I'll add that to my chart, 118.21 degrees. Now, I could do law of cosines again. However, most people don't like to do that because law of cosines is a bit time consuming, and people prefer law of sines. And at this point, since I now have an angle side pair, I can switch over and actually do law of sines at this point. So that's what I'll do to find my next missing angle. So sine of 118.21, that's sine of angle B, over side B, this is the way law of sines works, equals. Now with law of sines, I'm going to find the smallest angle first when I have a choice. My smallest angle is going to be angle A because side A is the smallest. I suppose you could argue it doesn't really matter. There's not going to be another obtuse angle in this problem. A triangle can only have one obtuse angle, so I don't have to worry about another obtuse angle, but just to be consistent, let's find our smallest angle first. So I'll do some cross multiplying. 27 times sine A, not much I can do with that, so I'm just going to write 27 sine A equals, I'll cross multiply the other way as well and just type all that in my calculator. So 11 times the sine of 118.21, that comes out to be about 9.69. And what I'll do to find side or angle A then is let's divide by 27. And so sine of angle A is equal to about 0.3590. And finally doing an inverse sine, once again doing inverse sine to find a missing angle, an inverse trig function, I find that angle A comes out to be approximately 21.04 degrees. So let's also add that to my chart just to kind of organize my thinking. So 21 0.04. And finally, now that I know two angles, let's just keep this real simple and use the fact that all angles in a triangle always add up to 180 degrees. So subtracting the two angles I've already found from 180 tells me that angle C is going to be 40.75 degrees. Now I know these are long problems and you want to be done with them, but a quick check that I like to do is just make sure that your biggest side and biggest angle are opposite each other. They are. And make sure the same is true for your smallest side and smallest angle, that they're also opposite each other. If they're not, then something's gone wrong. But there we go. We've solved this triangle using both the law of cosines and the law of sines to find out all three sides and all three angles about the triangle.